So, my name is Brian Hutchison. I'm a professor here at Victoria College, and today I'm actually going to tackle a older problem from our video repertoire. So one of the videos we did almost at the beginning of a semester for 13-14 would have been where we can take a lump sum of money, split it into two separate accounts. Each account earns a different interest. And then we make a total, and it usually asks, hey, how much was in each one? So we had $50,000, excuse me, not in blue. So we had $50,000. We're going to split it into two accounts. One earns 8% and the other one earns 4%. Remember, you don't put all your eggs in one basket. And your yearly interest earned would be $3,200. And the way we tackled it on the first video was that basically principal times rate times time gives me interest. And we did it in chart form. And I'm still going to start this one in chart form. So one interest was 8%, the other interest was 4%. It's still just 1 year. But we have to have a question, and the question is, how much was invested into each account? How much was invested into each account? So is there anything wrong with the way we tackled it at the beginning? And the answer is no, it's perfect. But there was a little catch, right? We know we had to put X for the first amount because it's one of the things we're looking for. But this next one, right, we had to put in 50,000 minus X. The rest of the money. And at the end of the video, I warned you that maybe we don't want to put a Y, another variable, into this thing. But this video is made for the end of college algebra, when you're tackling systems and matrices. You should now know how to solve for something that has two variables. If there's two variables, you need two equations. So we're going to tackle this guy different. I'm going to say we're going to call this guy Y. I need to know what X is and I need to know what Y is. It's exactly what is being asked by my question. And it really does at the beginning make everything look cuter. So my interest for the 8% account is 0.08 times X. My interest for the 4% account is just 0.04 times Y. And what do we know? Those two interests have to add up to $3,200. So 0.08X plus 0.04Y has to be equal to $3,200. But we have a problem. And the problem is, if I told you to solve, it's like, well, I can't just solve. I have an X and a Y. We could try to graph this guy, get a nice line, but a line is an infinite number of points, which means we could have quite a few different answers. But the trick is, I need one more equation. Something that is already given to us. And if I can get one more equation that puts x and y together, builds that relationship, well, then I would have two variables and I would have two equations that I can basically solve simultaneously and see where they intersect. They're both basically lines, right? Well, I do have one that x plus y has to be $50,000. This is my system. This is what I need to solve. Now, there's several different ways to solve this. One is with a matrix. One of them is the addition method, which is also called elimination method. And the other one is substitution method. I challenge everybody to do substitution. All right? Because when you do substitution, let's just say you solve for y, right? We'll subtract x, and we get that y is nothing but 50,000 minus x. And guess what? In the first video, that's what I told you to put in for y, right? Well, we didn't know why, but it's what we put right here. It's almost like we were tricking you to do substitution back on the second or third day of college algebra. Aren't we sneaky? But, like I said, I don't want to do substitution method because we've already seen that thing. I'm going to do addition method. So, once again, I have two equations, and I really don't like those decimals. Some of y'all can keep the decimals. Most professors will not even harp at keeping those decimals. But I don't like those decimals, and I'm going to multiply that top equation, equation number 1, by 100. It's legal, right? Which would give me 8x plus 4y is equal to 32,000,000. I'll multiply through by 100. Why would I do that? Well, now I can easily kill off either the x's or the y's. Because there's my favorite number 1 there, and there's my favorite number 1 there, and I don't have to multiply something by like 0.04 or 0.08. Now I get I can make a choice. Right? What's y'all's favorite number? Or what's y'all's favorite variable, x or y? I'm going to kill off the y's just because I need to move on with the video. Well, if I want to make this guy go away, I need to add a negative 4y to it. Which means my equation 2, I need to do negative 4 times this equation 2. So the 8x plus 4y, so I'm doing the addition or the elimination method, is this guy, but I'm changing equation 2. So negative 4 times 1 is a negative 4x, ditto. And negative 4 times 50,000 is a negative 200,000. So I am basically doing addition. Straight up, the y's went away. 8x minus 4x is 4x. And then if you went back and looked at the first video, you should be saying, Brian, this looks similar. And I'm like, everything's similar. It's a lot easier to set up this way too. So this gets me to 120,000. Divide by 4, divide by 4. I get x is equal to 3,000,000. Well, if x is 30,000, right, I can go back to one of these. What must y be? Well, I can also look right there. If x is 30,000, y is 50,000 minus 30,000, which is 20,000. So y must be 20,000. This one happened to be the 8% account, and this one happened to be the 4% account. So I want to challenge you. I want you to try this, right, using substitution. Right? But like I said, I've already showed you that in the chart method long time ago. But also try it as a matrix, right? An augmented matrix, and it works out pretty nice also. So other than that, we have another problem with a way to solve it. But I cannot express enough that word problems don't have to be nasty. Right? You just got to get past the word problems. Focus on the question at the end. Let your variable represent and solve that question. Right? Use your formulas. Set up charts. All of this stuff is called mathematical modeling, and the more you do it and the better you do it, it won't just help you in math, it'll help you in life. Right? It'll help you in life. Logically breaking down and or solving problems. So other than that, I hope everybody has a good day, and